Hey everyone, and welcome. We're about to dive into something that you're experiencing this very second, even though you can't see it. It's the invisible world of force, these constant pushes and pulls that are shaping absolutely everything around us.
So, let's kick things off with a question that I bet you felt the answer to, even if you couldn't put a name to it. Why is it so much harder to pedal a bike uphill compared to just cruising on a flat road? What is that invisible thing that's fighting you every step of the way?
Well, that feeling, that struggle, it's all caused by one single powerful concept. And getting a handle on it is key to understanding, well, pretty much everything. So let's jump in. Welcome to the world of force. We're going to figure out what this invisible thing actually is.
So what is it, really? Scientifically speaking, a force is just a push or a pull that happens when one object interacts with another. And that right there is the magic word, interaction. Nothing just decides to move all on its own.
Okay, so let's make this real. Let's talk about the forces we feel every single day. The most obvious one is a push. You see a box, you want it to move, you apply a force, you push it. Simple as that.
And the other side of that coin is, of course, a pull. Think about opening a drawer, or maybe dragging that same box with a rope. It's the same idea, just coming from the other direction.
Even lifting something is really just a special kind of pull. You're pulling that object up. And what's really interesting is that you're fighting against another force that is always pulling things down. Don't worry, we are definitely going to get to that mysterious downward pull very soon.
Okay, so we've got our definition. A force is a push or a pull. But so what? What can a force actually do in the real world? Let's take a look at the actual effects you can see and feel. Turns out, any force, and I mean any force, only does one of four things. It can make something move that was sitting still, like kicking a soccer ball. It can change the speed of something that's already moving, like a baseball fielder catching that ball and bringing it to a stop. It can change an object's direction. And number 4, it can actually change an object's shape, like when you squeeze a balloon.
Now, to make things a little easier, we can sort all of these forces into two big families. On one side, you've got contact forces. These are the ones that need to physically touch something to work. And on the other side, you have non-contact forces. These are the ones that feel kind of like magic because they work from a distance.
All right, let's dive into that first category, the one that makes the most sense to us. We're exploring the forces that touch.
We're going to focus on two big ones here. First, there's muscular force. That's pretty straightforward. It's the power your own body creates to push, pull, and lift things. And then there's friction. Friction. It's that pesky force that always seems to be working against you, trying to slow everything down.
So what's actually causing friction? Well, our source material explains it perfectly. It says, friction arises due to the irregularities in the two surfaces in contact. What that means is that even surfaces that look perfectly smooth, like a tabletop, are actually covered in tiny microscopic bumps and grooves. And when two surfaces slide past each other, those little bumps get caught on each other, and that's what resists the motion. It's the reason a ball stops rolling way faster on a bumpy lawn than it does on a smooth, polished floor.
Okay, now for the fun part. The forces that seem a little bit like magic. Let's talk about the invisible, non-contact forces. These are the pushes and pulls that can reach out across empty space without anything physical touching at all.
And to get our heads around this, let's think about a classic little science experiment. How is it possible for a regular plastic ruler, after you rub it on your sleeve, to suddenly get this superpower where it can pick up tiny pieces of paper without ever even touching them?
Well, that magic has a name. It's called the electrostatic effect. When you rub that ruler, what you're actually doing is building up static electricity, these tiny charges all over its surface. It's now what we call a charged object. And that charge creates this invisible field of force all around it, which can then pull on other things.
And that brings us to the formal definition. Electrostatic force is the force that a charged body exerts on another object. And here is the golden rule you have to remember. Like charges repel, they push each other away, while opposite charges attract, pulling together. It's the exact same reason that if you rub two balloons on a wool sweater, they'll actually push each other apart.
All right, let's move on to the last, and maybe the most epic non-contact force of them all. This is the one that literally holds our entire universe together. We're talking about gravity, the ultimate pull.
Hey, remember that mysterious downward pull we talked about when you lift something? Well, this is it. Gravitational force is the pull that a huge object, like our planet Earth, exerts on everything near it. And here's the thing about gravity. Unlike electrostatic force, it is always attractive. It only ever pulls. It's the reason why a ball you throw up in the air will always come back down.
But talking about gravity brings up one of the most common mix-ups in all of science. What is the actual difference between an object's mass and its weight? I mean, come on, aren't they just the same thing?
No, they are absolutely not the same thing. And here's the breakdown. Mass is the amount of stuff you're made of, the amount of matter. That number stays the same no matter where you go in the universe. Your weight, on the other hand, isn't stuff at all. It's the force of gravity pulling on your mass. And since the force of gravity can change depending on where you are, your weight can change too.
Just look at this table. It shows you exactly how different they are. Take a look at that mass column. For a 1 kilogram object, it's always 1 kilogram, right? Earth, Moon, Jupiter, doesn't matter. The amount of stuff doesn't change. But now look at the weight column. On the Moon, where gravity is much weaker, that same object would feel super light. But take it to massive Jupiter, and it would feel more than twice as heavy as it does right here on Earth. Same mass, totally different weight.
So when you start to put all these pieces together, you realize that from the friction that lets you walk to the gravity that's holding you in your chair right now, these invisible forces of push and pull are shaping your experience of the world at every single moment.
We've just pulled back the curtain on some of the universe's most fundamental rules. So now that you can see these hidden forces working all around you, what are you going to notice next?